Hello everyone, welcome to our presentation for AWS Architecture Solution for Financial Organization. We are Group 12 and I'm Adil Araf and my partner is Syed Mesbah Hassan. The two-person group, I will be responsible for sharing the storage components and security in AWS and the rest part will be handled by Mesbah. Jumping on to AWS, first item that we need for the storage facilities is the KMS, that is Key Management Service. So we have already made a KMS, that is our personal key. We go into the key and we can see that it has a policy. It means we can set what policies and what objects from AWS we can use with this key. So we can see in this policy that there are IAM user permissions, there are Elastic Load Balancer, and there's S3, and there are others as well. And it also has cryptographic encryption with symmetric default, and it has the usage for encrypt and decrypt. Next, we can see what are our storage components. So we have AWS S3, Glacier, DynamoDB, and RDS. S3 is basically a scalable object, and the Glacier is used for long-term manage effective process. DynamoDB is a NoSQL process in AWS, where we can actually use the database with NoSQL commands. And finally, RDS, where we can use our traditional database structure with Postgres or MySQL to transform our system from in-house to the cloud. So now I'll move on to these components in AWS. Starting with Amazon S3, which is the highly efficient storage component, we can create a bucket here. So we can go to create bucket and we can fill all the necessary information with general purpose tools bucket. We can ACL enabled because we need it for security purpose. We can block all the public accesses. We can enable versioning so that we can get the older version. And finally, we can encrypt it with the KMS. So as we have already made the bucket, we cancel it here. And we can see the bucket here. And if we go to the properties, we can see that bucket is in this region and has bucket versioning enabled with our own personal KMS. With that is, it is encrypted with our own key. Next thing is AWS Glacier, which is a long-term component for the storage function. We can create a vault in AWS Glacier where we can give the vault name, and we can also turn on notification in the SNS. So whenever we get any information or whenever any data is going in or out of the AWS Glacier, we can get the notification. So for its function, we can go back to Amazon S3 and we can go to management and we can set the lifecycle rule here. So the lifecycle rule is here AWS S3 cost saver, where we can move the information from one S3 to the S2 Glacier in 100 days. So if the data is not used in within 100 days, it will be moved to AWS Glacier, which makes the system much more efficient and cost effective. The next item is DynamoDB. In DynamoDB, it is a NoSQL database. It means it does not require any coding. And to work with DynamoDB, it is very fast and it is compatible with AWS and it can be used in any applications. So we have to first make a table here. You have to fill the table name, the partition key, and the settings as well. So as we have already made the key, I cancel it here. And this is one of our table. This is one of our table that we have made for our purpose. We can see that there is a partition key as well as there are some items here, but there's only one item that we have given for the test purpose. We can click on explore items to see what items are here. There is one item that is CloudSec, and that is in Dynamo, this is the one, DynamoDB. We can back up all the items in the DynamoDB as well as we can export S3 for our security purpose to get any information out of AWS or get into AWS. We can also use import S3 and it has all the functions that we can use. So it can also be used to create a backup. We can schedule backup and we can create an on-demand backup. Finally, it comes to the Amazon RDS, which is for the traditional databases. We can create a database here. We can go to create database. We can give our own languages. We can create a standard create. We can give MySQL here. We can give the engine here, and we also have to give the engine version. We can choose the latest one. We can choose the latest one, and we can give the availability. It has to be multi-zone available, and it has different storage. It has to have an allocated storage, and cancel it here because we have already made that one. We get into the RDS database. We can see that we have used only a very little amount of the CPU, and has the availability zone. It also has separate VPC and different subnets, and with our own preferred security zone here. The next thing in the architecture is security in AWS. To do that, we have used four major components that AWS offers for security. One is AWS CloudTrail, then CloudWatch, then GuardDuty, and WAF, which is Web Application Firewall. In CloudTrail, the user activity tracking is ensured with security audit logs. In CloudWatch, the infrastructure health monitoring is done with application performance metrics, where we can see all the metrics that is associated to an application with event-driven log characteristics analysis. In GuardDuty, there's threat detection service that can actually monitor all the malicious activities. And finally, in WAF, there is web threat protection with customizable security rules and real-time traffic monitoring. Now I will move to AWS to show the scenarios. Starting with AWS CloudWatch, it provides us with the alarm feature and as well as event-driven log characteristics, which will help us to monitor the security over all the infrastructure. To do that, we can set up the alarm in all alarm. Here we can see that we have already set 2 alarms before. So if we create a new alarm, we go to create alarm. We have to select a matrix. For example, we can select billing, and we can also select total estimated cost. There's only one category, so we can select the matrix. And finally, we can give a threshold here with $1,000, and then we click on next, and we can select an SNS, which will give a simple notification service. And finally, we can also again click next. We can give a name, any name here, billing, and we can go next, and finally the alarm can be created. So this is how AWS CloudWatch can help us to monitor all the activities in the cloud structure with the alarm, where we can send the threshold, and if the threshold crosses, we can actually see we can also get an alarm, and we can also see how things are in the architecture. Next item is AWS CloudTrail. AWS CloudTrail mainly helps with the event-driven logging history. So we can make a trail where the trail. Next thing is AWS CloudTrail. AWS CloudTrail is mainly used to record API activity with resource changes. AWS CloudTrail, we can actually log all the events, and we can see all the events happening inside our infrastructure. So we have already made a event trail with our name. So we can see that the status is logging and has the location storage, which is in our S3. It has storage in our S3, and it will log all the events in our S3 bucket. It is also enabled with an SNS notification. Whenever there is an anomaly or anything that goes out of the hand, we will get a notification through the SNS system. If we go to our event history, we can see that all the logs are created here. We can see that we recently made put metric alarm. It is logged here, and console login, get sign-in token, and everything is logged in here. So if we want to check everything that is happening with our system, we can easily go to our S3 and find the CloudTrail. The third item is Amazon GuardDuty, which actually works with threat detection, continuous monitoring, anomaly detection, and security alerts. So we can see that here are no severe findings. It shows that our system is well protected from any malware. However, I tried with a dummy malware to launch an attack. So we can go to the findings and find that. So we can see in the findings that there are 2 items that it has already found that be a potential malware. One is brute force and another is bind attack. And we can also see from the GuardDuty procedure that it is binded with protection plans. It has spray protection, it has case protection, has runtime monitoring, as well as protection for EC2. All the items are logged here. Lastly, we have WAF, that is Web Application Firewall. So this is the WAF Shield dashboard, and it shows that there is currently no firewall activated because there was no anomaly detected. We have activated bot control dashboard. That means if our website is attacked by a bot, it can detect it and also it can send the data to the user. So like this bot, there are many other web firewall applications that can be used with different charges, with different prices.
Hello everyone. This is Syed Mesbahul Hassan. Um, Now I'm going to talk about my part. Uh, from the beginning, my roommate, my groupmate Adilana already discussed about his sections. Now I'm going to talk about my topic is AWS architecture solution for financial organizations, and my group member is me myself, Syed Mesbahul Hassan, and another one is Adil Ahnaf. Um, and topic to be covered like my core topic is on VPC, subnetworks, security groups, and gateway, identity access and management, and organizational policy. And I've discussed so far about virtual details in virtual private network clouds, um, and routing table as well, security groups, subnetworks, net gateway, network access control list, security groups, and now I'm talking about the virtual private cloud. Basically, mm, I have created two virtual private cloud on my AWS, and so far as virtual private clouds in a AWS is a customizable virtual network that provides isolated networking for my resources, allowing control over IP ranges, subnets, routing, and security settings. It also enables internet and VPN access, secure internet, VPC connectivity, and creation of public and private subnets as well. So, as I discuss over my presentations, um, I have created on AWS so far. So now, oh, I'm going to the part. So here I created the one VPC over here, two VPC account actually. I have created my VPC and my VPC VPC. There's these two VPC. So so where's my VPC ID, and there's state is of and I have created put in my own IPv for 15.0.0 by 16, and uh, this is CIDRs, float logs, and integrations as well for my VPC. There next, I'd like to talk about the sub networks. So so uh, next, I will talk about security groups. For the in AWS, maybe security groups acts as a virtual firewalls for my resources, controlling inbound and outbound traffic based on defined rules. They help security resources by allowing or blocking specific types of network traffic. So that's how I described security groups. Now I'm going to my AWS. So I have created security groups over here. So security groups over here, I have created this one, Milspa demo. My name is Milspa, so I have created this one. That one is a default. So if I go to the security groups, here's a different name and group security groups ID and the description as well. Here I connect my VPC ID over here, and there's some inbound and as well as some outbound as well for my security groups. Next, I'll go to the sub networks. Here I created my sub networks. Is two of them are private and two of them are private public, and so In AWS, subnets divide a maybe subjects basically divide a VPC into a smaller network segments, allowing my to organize resources and control traffic flow. Subnet can be public or private. This is I have already created public and private one, enabling secure architecture setups with the within the VPC. That's how it works. Like if I go to this one, my public one. So for the routing table, I have created one routing table as well. Here you can see the two top subnets explanations over here. So many snow in my routing tables also um, have a target always is already active. Have the local, this is my local one. So that is my internal gateway. Here is my internal gateway. So here is my internal gateway ID. Uh, that's routing table basically. This routes already connected to subnet associations. Uh, Here it is. So next I'm going to talk about the NAT gateway. So next I'll talk about the NAT gateway. So I have created a NAT. It's Mezwan NAT. It's my source. It's a connect ID connectivity is public. So may in NAT actually in what NAT gateway actually do an NAT gateway allows resources in a private subnet to access the internet for updates and downloads without exposing them in bound internet traffic, ensuring security while enabling outbound connectivity. Basically, so uh, if you go to the network ID, so I get my ID, connection type is public, so it has the address available. So if you go into the monitoring section, uh, it's taking time. So uh, here it is. So then I just work on IA basically. um IAM. Here, yeah, I can access and identify the management. Maybe in AWS, identity and access management manage user permission access to resource. It allows you someone to create control users groups and roles, set permissions, and enforce policies and ensuring secure and control access your account. I just wanted to create a user over here. I have tried to create a user. If I create a new user over there like Mespa or something that I can easily create if I have a permission over here. So that I don't have a permission. So I tried a lot to get a permission over here, but I couldn't create a user because it's not permitted over here. So that's why I couldn't create the user. That's how I can create roles as well, policies over here, so that I can use the policies in IDMS. This is organization activity as well. Without user is cannot possible to be a role name, and that's how I create. That's how can anyone create a policies. So that's how it works. And as I cannot access the user, so that I cannot do the MFA1 because without user it's not possible to do the MFA1. And now I'm talking about the network access control list. So for the network and access control list, I think the E2. Here you can see the EC2 already in here. Some network spaces, some already provided. And that's all from my side. Thank you so much.